In the history of technology, a select few individuals stand out as true pioneers, blazing trails and shaping the future. Today, we celebrate one such visionary, Grace Hopper, a remarkable woman who not only helped usher in the age of computers, but also championed the idea of making programming more accessible and user-friendly. So buckle up and get ready to delve into the fascinating story of Grace Hopper, the Grande Dame of Code. Imagine a world before personal computers, before user-friendly interfaces and intuitive programming languages. This was the reality when Grace Hopper, a brilliant mathematician and trailblazing naval officer, first encountered the colossal Mark I computer in 1943. Undeterred by the complexity of the machine, Grace embarked on a remarkable journey that would forever change the landscape of computer programming. From mathematician to codebreaker, a life of dedication born in New York City. In 1906, Grace Brewster Murray displayed a natural aptitude for mathematics and science from a young age. Her thirst for knowledge led her to pursue a PhD in mathematics from Yale University. Following her academic pursuits, Grace joined the U.S. Navy Reserves in 1943, motivated by a desire to serve her country during World War II. It was during this time that her path intersected with the world of computing. Assigned to the Bureau of Ordnance Computation Project at Harvard University, Grace encountered the Mark I, one of the first large-scale electromechanical computers. Despite having no prior experience with programming, Grace's keen intellect and mathematical background allowed her to quickly grasp the inner workings of the machine. She became a key member of the team that programmed the Mark I to calculate ballistics tables for the Navy, playing a vital role in the war effort. Do you think a strong foundation in math and logic is still beneficial for those interested in pursuing a career in computer programming today? Debugging the first bug, a pioneering spirit, one of Grace Hopper's most famous anecdotes, often recounted with a touch of humor, involves encountering the first recorded computer bug, a literal bug. While working on the Mark I, the team encountered a persistent malfunction. Tracing the issue, they discovered a moth lodged within the delicate machinery of the computer. This seemingly trivial incident highlights the meticulous nature of early computer programming. Unlike today's computers with sophisticated error messages and debugging tools, the Mark I required a deep understanding of its physical components and the intricate interplay between hardware and software. Grace's meticulous approach to problem-solving shone through in this instance. She not only meticulously documented the issue, but also carefully removed the insect, forever immortalizing it by taping it to the program logbook with the inscription, "First actual case of bug being found." This seemingly insignificant event holds a deeper significance. The term bug, often used figuratively today to describe any software error, originated from this very incident. Grace's detailed log not only helped pinpoint the physical cause of the malfunction, but also gave birth to a now ubiquitous term in the programming world. The story of the first bug serves as a reminder of the ingenuity and resourcefulness required in the early days of computing. It also highlights Grace Hopper's pioneering spirit, her ability to not only solve problems, but also to find humor and share her experiences in a way that made computer science more relatable and approachable. Beyond the machine, championing user-friendly programming. While Grace Hopper excelled at wielding the complex code of the Mark I, her vision extended far beyond the intricate workings of that specific machine. She recognized a fundamental limitation in the early days of computing, the programming languages themselves. These languages were often machine-specific. Each computer had its own unique instruction set, requiring programmers to learn a new language for every machine they interacted with. Imagine needing to learn a completely different language to program your phone, your tablet, and your laptop. This not only hampered innovation, but also limited collaboration, as programmers couldn't easily share code between different machines. Cryptic and symbolic. Early programming languages relied heavily on numbers, symbols, and abbreviations that were difficult to understand for anyone without a strong foundation in computer science. Think long strings of seemingly random characters that bore no resemblance to human language. This created a significant barrier to entry, limiting the pool of potential programmers to those with a strong math and engineering background. It effectively shut out individuals who might have had brilliant ideas, but lacked the specialized knowledge to translate them into code. Flowmatic. In the 1950s, Grace played a pivotal role in the development of Flowmatic, one of the first compilers, a program that translates human-written code into machine-readable instructions. Flowmatic used English keywords and a more natural structure, making it significantly easier to learn and use compared to the machine-specific languages of the time. Imagine the possibilities that opened up. Suddenly, individuals with a basic understanding of logic and problem-solving could begin to interact with computers and create programs, not just those with a deep background in computer science. COBOL, Common Business-Oriented Language. Flowmatic paved the way for the development of COBOL, another high-level programming language designed specifically for business applications. COBOL, with its focus on readability and maintainability, became widely adopted in the business world. This further demonstrated the value of user-friendly programming languages, not just for scientific computing, but also for everyday business processes. Imagine a world where businesses could develop custom software solutions without needing a team of computer scientists on staff. Grace Hopper's unwavering belief in the power of user-friendly programming not only simplified the process for programmers, but also laid the groundwork for the development of more intuitive interfaces and user-friendly experiences that we take for granted today. Her legacy reminds us that technology should be accessible and empowering, not an exclusive domain for the technically elite. By championing user-friendly programming, Grace Hopper helped democratize technology, opening doors for a new generation of innovators and paving the way for the digital world we know today. Can you imagine a world where anyone, regardless of their technical background, could easily create programs or interact with computers using natural language? How would this impact society? A legacy of inspiration. Paving the way for the future. Grace Hopper's influence on the world of computing extends far beyond her groundbreaking work on the Mark I or her contributions to programming languages. She was a passionate educator and mentor, inspiring countless women to pursue careers in computer science and engineering at a time when these fields were heavily dominated by men. Her unwavering belief in the potential of technology and her dedication to making it more accessible continue to inspire generations of programmers and innovators. Grace Hopper's remarkable journey from mathematician to codebreaker to champion of user-friendly programming is a testament to the power of human ingenuity and dedication. Her legacy reminds us that technology can be a powerful tool for progress, but only if it is designed to be accessible and inclusive. As we move forward in the ever-evolving world of technology, let's remember Grace Hopper, the Grande Dame of Code, and her unwavering belief in the potential of technology to empower and inspire. If you're interested in learning more about Grace Hopper or the history of computer programming, leave a comment below. And if you enjoyed this exploration of a true technology pioneer, be sure to like and subscribe for more inspiring stories about the minds that shaped our digital world. Until next time, keep exploring and keep innovating.